once again, this is Jeff Scott at Blackhawk Technical College. The class is 152-142, Intro to .NET Programming, C# for the spring 2015 semester. And right now I've decided to go off on my own, so to speak, and do the lecture for Chapter 8, which is more on processing data. I may do this for 8, 9, 10, and 11. We'll see how it goes, okay? So I'm on page 465 in the book, more about processing data. This is kind of a hodgepodge or a miscellaneous chapter in that there's a lot of different things that are covered that I believe at least that what Gaddis decided was he had some topics that didn't exactly belong with anything else. So we'll talk about string and character processing, structures, enumerated data types, and finally the image control. First, Gaddis goes into a lot of depth in here and talks about a lot of the different string functions, okay? And when you're working with string functions, you've got your choice. So if I go and create a string, all right, so if I come through there and I type in string, name equals Jeff, all right? Really what that is that's the same thing as saying char, let's say FL for first letter, equals J, char second letter, equals E, char third letter, equals F, and char, in fact, I'm going to use this. This is a crummy way. Let's do it. L1, L2, L3, and L4 equals F. Now you might think, looking at that these two are identical, but technically they're not, because in memory, what happens is the system, when it puts that in there in memory, so again, I'm going to draw a very crude picture here, but if we draw something, and if you can imagine that this is memory in here, all right, so you've got J, and then you've got E, and then you've got F, and then you've got F as an example, all right, just so you can see what I'm talking about here. All right, and you probably think that pretty much that's the way that it looks. And of course, again, it would be the zeros and ones that are in there. It wouldn't actually be the J, E, F, and F. And it does look like this, except that when you have an actual string like you have right here, it also puts a special character on the end, which is \0. And that \0, for lack of better words, what that means is you've reached the end of the string. So it's a string termination character. Now, so that's the way it would look, for example, for this. But for this, it would look like something like this, but without this. The other thing is, since this is an array, really, basically a string is a character array, you can be assured that those letters in memory are going to be contiguous, one following the other. If you set them up as 4 individual characters, you don't have that assurance. But what I wanted to show you here was, again, when we have strings, you put it in double quotes. Chars, you put in single quotes. All right, and they do talk about that right here. They break it up into 2 statements here on 466. All right, so retrieving the first character. All right, so again, they're using a string here, and I guess that thinking a Java on the mind, because it probably is a little s. Okay. So string name equal Jacob, and if you say letter equals name 0, you get J. All right, you get the letter J. So they show you one way here that if you wanted to do this, you could iterate your way through a string, a character at a time. The reason that that's important is if you're doing input, and let's suppose that you're inputting where the only acceptable characters that you have for a person's name, let's say for a first name, they can have either A through Z, upper or lowercase, all right, or a hyphen, or maybe a blank space, something like that. If their first name was considered to be like Juan Carlos or something, maybe Juan space Carlos or Juan hyphen Carlos type of thing. So you could go through and allow them to input it into a string and then check it a character at a time. And if they put something in there that was considered to be an unacceptable character, you could then refuse to accept it. when you do this, when you set up a thing like this, strings are what's known as strings are immutable. All right, what does that mean? That means that if later on in my program where I've got this string name equals Jeff, I decide I want to be more formal and I want to say name equals Jeffrey, it's not like the system finds where this is in memory and adds an REY onto it. No. It basically, it marks this as being now unused memory, and it recreates this someplace else in memory, and then it adds into it the R, the E, and the Y, and then the \0. All right, but there are two different memory locations, and that's what I want you to understand. It may sound like it's very minor. It's really and truly not minor. It's actually an important concept for you to pick up and understand. Strings are immutable. That means they cannot be changed. So once you create them, when I say they can't be changed, of course you can go from here to here. But what happens is it goes to a different spot in memory to make the change. And then it takes that original spot and marks it as being unused. So when something that's called the garbage collector comes around, it can remove that from memory. All right, and they explain that in here. Now there's a boatload of different string methods and character methods. Here's some of the character methods. Is digit, is letter, all right? Is letter or digit, is lowercase, is punctuation character, is uppercase character, is a white space character. And you can understand all those. I'm sure you can. As always, I'd always recommend going out to MSDN. In fact, if I go to Google and I put in C# character methods, I'm willing to bet you that the first thing that comes up is something from MSDN. And there it is. The character methods, there they all are. So if you want an even bigger list than the ones that are in your book, and I'll try to remember to save this when I get done. So C# character methods. It's right there. Okay? So there's a lot of different things that you've got available to you. Then they've got this program here that starts on page 471, completing the password validation application. So you're telling a person to put in a password, and you're putting in these constraints. Must be at least 8 characters long, must contain at least one uppercase and at least one lowercase character, and at least one digit. So you have them put that in, and then you write the code that runs these different functions. All right? So notice here we're checking uppercase, here we're checking lowercase, here we're checking whether or not it's a digit. Could we do all those inside of one loop? The answer is yes. We could have written just one loop in here because they all say for char, ch, and str. So we could have taken that if statement, and that if statement, and that if statement, and put them all inside of the same for loop and had 3 different counters. Made them global, had a digits counter, a lowercase, and an uppercase counter. We could have done it that way too. There's plenty of different ways that you can do this. The conversion functions, 2 lower or 2 upper, my guess is you already understand this, but if I've got a string like this, and I run the 2 lower on it, it looks like that. And most often it's used when people have mixed case. So again, if I run the 2 upper on this, I get this. If I run the 2 lower on this, I get this. Substrings, same kind of thing. If I come in here and instead of saying character methods, I change this to C# string methods. Again, notice it's MSDN. And you're going to notice the same kind of thing. Those are all string methods. I don't know how many of them there are. There are scores of them, though. Like I said, I'll try to remember when I get done to take and save this, so if anybody has an interest in it. So I've now given you the character methods and the string methods. I'm not going to sit and read from the book because they've got charts that go on page after page after page. Most of the things that are in there, as far as these different methods, they're pretty self-explanatory as far as the name goes. You'll notice there are a lot of string functions that allow you to search for a substring. And they have an example, it's either in this book or the Java book, I don't remember, but where they go in and they say, well, imagine that you're going through the Gettysburg Address. Okay, and you wanted to check for how many times the word ago was in there, as an example. You could do that. You could basically run that in there, put that in as an input string and tell it to search for how many occurrences of it there are. If I wanted to see whether or not the Gettysburg Address began with 4 and 7 years ago, there are different string functions I can use for that either, or also, I should say. So again, there's just page after page of these. All right. Again, more stuff. So you can take strings and do all sorts of different things with them. Kind of a neat program here that starts on page 484, completing a telephone format application. So the idea is you can put in a phone number like this, and it'll strip off the parens, and it'll strip off the hyphen. So it'll look like this. Or you can go in the other direction where you put it in like this, and you change it to this. Now, it wouldn't take much work to change that to the way this looks here with a space in there. You could have done that too, but they do it like this. All right, so it says enter a 10-digit number, and I will format it as a phone number. So you put in your 10-digit number, and it goes through it a character at a time. And it does the conversion. Okay. All right, next they talk about tokenizing strings here. Okay, and with this, if you looked right here, forget about the double quotes that are there, but imagine you had a string that said peach, raspberry, strawberry, vanilla. What this actually is it's a string that's made up of 4 different words. Each of those words is separated by a blank space. The blank spaces are what are known as your, basically your tokenizing character. And the tokens are peach, raspberry, strawberry, and vanilla. Now, when you think about this, we live our lives. If you look at the book here, this book is made up of what? This book is made up of chapters. Each chapter is made up of pages. Each page is made up of paragraphs. Each paragraph is made up of words. Each word is made up of letters. And it's the same kind of thing as you're starting to tokenize. So if you walk into class the first day and you've never met me before and I say, good morning, how is everybody today? So good morning, how is everybody today? That's 6 different tokens. All right? So there's where you're using a blank space to separate your tokens. Here's you're using semicolons. Here's one where you're using commas. All right, so it just depends. You can tokenize with anything. You can even tokenize with more than one character. Quite often you have what's known as a CSV, or a comma-separated variable file. And so you've got a list of values that look like this. And the way that you can tell when one ends and the next one starts is they have commas between them. All right. Here we could take this and say that this is a date, and our tokenizing character is the hyphen. So we could break this up into 3 fields, those being a month field, a day field, and a year field. All right. Usually when you do that, you use what's called the split method. And again, that's discussed in here. I don't want to spend a lot of time going through this. I really don't. The program's fine. But this is kind of a good one here. This example that starts on page 494, completing the comma-separated variable reader application. A professor keeps her student scores in an Excel spreadsheet. All right, 5 test scores for each of 5 students. So each column has a test score, and each row represents the test scores for 1 student. So if that was me, that would be my test 1, 2, 3, 4, and 5. All right, if that was my wife Sandy, that would be hers. My daughter Taylor, my daughter Mackenzie, my daughter Chloe. You get the idea. So it says, suppose the professor wanted to write a C# app that reads the test scores from the Excel spreadsheet and performs an operation on them. So we put this first into a comma-separated variable file like this, and that ends up, when we do the get scores, that ends up being our input. And once we have that, we can run any of the functions on there we want to. In this case, we're doing something different. For each student, we're adding up all 5 of his or her test scores and dividing by 5 to give them their average. All right, before we go on, because I am going to, and talk about structures, let's go into the virtual desktop, and I'm sorry I didn't bring it up yet today. So all right, and I've written one of the programs. I don't remember which one it was, but I remember I wrote one of the programs here for the chapter. And let's see. Probably is in here. It's not there. I know that I wrote it. In fact, let's do this. Let's see if I can let the system find it for me. Unless I moved it. So I know I did it, unless I did it at home. I thought I did it here. Let's look at the completed progress. There we go. Chapter 8. Of course. Oh boy. Well, that's interesting. I can't find where I put them. I'm trying to remember where that would be. That's 4 weeks of class. That looks like it might be it. All right, so this was the program that I will go over with you. I guess I did have it there. This is a program from out of your book. All right, you can see it's got a very simple interface, but it's a program that's at the end of Chapter 8. Programming Challenge 8, Sum of Numbers in a String. Write a C# program that asks the user to enter a series of numbers separated by commas. Here's an example of valid input. 7, 9, 10, 2, 18, 6. After you've entered all of them, the program should calculate and display the sum of all numbers. So in this case, it would be 7 plus 9, which is 16, plus 10, which is 26, and 2 is 28, and 18 is 46, and 6 is 52. So it should print out 52. In fact, let's keep that. We'll put that in there as our input. The nice thing about this, here's our clear button, and that clear button just clears this field, and it sets the focus back to our text box. All right, so that's all that does. Then we've got our exit button, which is our normal typical exit button. I did everything right inline here, but what I want to show you is That's the whole thing for the calculate. And almost I can get it to show on screen, almost the whole thing. So here's the calculate. So I'm saying I'm setting a string equal to whatever I put into this text box right here. All right? And then I'm saying my delimiter is a comma. So then I'm using the split method, which says basically what I want to do is I want to take this one string. So this thing, if I put it in like this, it's being put in as a string. So let me grab that. Oops. So I'm putting that in here as a string. And as far as the system is concerned, it literally is just that. In other words, it is a single entity. That's what that is right there. All right, that's what that string becomes. So I'm saying the delimiter is the comma that's between each one of these. Okay, then split it based off of the comma. So once I get done, that changes that into what you kind of would expect, and that is this. It is now 7 space 9 space 10 space 2 space 18 space 6. So it is now, instead of being one unit that has 6 parts, it is 6 units, each of which have one part. So then I say come through here and attempt to add up those 6 things. Notice I put it in a try-catch, because what if I put something non-numeric in there? I'll get non-number input, illegal, and it'll basically set my total equal to 0. And actually the other thing I should have done in here is I should also say text box as the answer. So what is the input field here called? Text box input. Okay. I should have really set that equal and blanked that out as well. Okay? And probably put the focus there. Okay? And then when I get done, if I have gotten to the bottom, if I put in all numbers, it's going to tell me what the total is. So let's run this and take a quick look. All right, so with output that is valid, the answer, the sum is 52. But if I try the other one, this should fail, because there is an invalid character, the blank space, in between each one of these. All right, so it says non-number input attempt. All right, and it removes that. It says the sum is 0. Okay, so I can put in any numbers I want: 1, 2, 3, 4, 5, 6, 7, 8, 9. 10, 11, 12, 13, 14, 15, etc. Those are all valid. Calculate, there's my sum. All right, I have no reason to think that's not valid. Notice 1, 2, 3 plus 4, 5, 6, that should be what? 579? And it is. But notice if I put a comma here, I'm going to get an error message, because it's expecting something to come after that. The thing that's nice about this particular program is its brevity. 1, comma, 2, comma, 3. Put periods in there. There's the sum, clear, exit. The whole program itself is 90 lines. And out of those 90 lines, what? The first 20 just about are comments. The next 10 just about are my using statements. So the actual code that we have in here to actually do the calculation starts on line 60, and it goes to line 90 or 89. So it's about 30 lines of code. You're going to get this. We're going to do this program as a class. All right. The next thing that's discussed in here are structures. And a structure, for lack of better words, is also known as a record. The thing about a structure is, if you look in here, you can combine different data types. So if I'm doing information about a car, I can have a string for the make of the car, an integer for the model year, and a double for the current mileage on the car. And you create structures and you have them look like this. All right, so it looks something like this. Looks a little weird because those data that are in there are public, and that's okay. But it's struct, short for structure, the name of the structure, and these are the components of the structure within curly braces. Once I do that, I can now create variables. So I could create a variable called Jeep that was of type automobile. And I could say Jeep.make equals Jeep.year equals Jeep.mileage equals. All right. So if we look in here, we set it up, that's kind of what it's going to look like. And you'll notice that if you had a sports car versus a pickup, they would look different. So when you go in to create a new one of these, notice what you say. Automobile, that new structure type, sports car, which is the name, equals new. So we're newing. All right, this is the first really object-oriented thing we've seen in a while in here, type automobile. So that thing right there has to match this thing right here. So we could create a sports car, a pickup truck, anything we wanted to. Once we create the sports car, then again, the valid things are sports car.make, and that must be a string. Sports car.year, and that must be an integer. Sports car.mileage, and that's a double. Notice you can assign one structure to another. These are not arrays. So if I do that and I say car2 equal car1, everything from car1 is copied over to car2. They're not the same thing. It's not an alias. They're two different structures, each of which hold the same value. You can pass an entire structure into a method. You can return an entire structure from a method. All right. Again, notice this. You cannot perform comparisons directly on structure objects. Much like arrays, you've got to write a loop where you compare things, an element in the structure at a time. You can create arrays of structures. Your structures can't hold arrays as elements. You end up with some weird looking stuff when you do this if you look right here. Cars, which is the name of the array, all right, I'm sorry, the name of the structure, index, which is the current array element, dot make. Totally legit to do that. In Chapter 7, we discussed the list class. Here's an example how you could create a list, a whole bunch of automobile classes. So again, that automobile, that's of type struct. So car list, each car list, all right, would be of type automobile, and each car list would hold what? It would hold a make, a year, and a mileage. And they give you an example here. Here they've got a phone book application, and what they do right here is you've got a list of your friends, and when you highlight a friend, the phone number appears in here. All right, this is, and the thing that's nice about this is very database-ish. In other words, when we get to the last chapter of the book, if something in here, that this was a list of people, then instead of bringing up the phone number, we would have first name, last name, address, city, state, zip, and all the database fields on that person. So you're going to see something like this again towards the end of the semester. So they create this phone book entry with a person's name and then their phone number. And they put the name in there as just one field, which is totally fine with what they're trying to do here. So they're showing you what it's going to look like. All right, you're going to have an array of these, basically. The first one will hold Katie Allen, the next one Jill Ammons, the next one Kevin Brown, etc. Hopefully taking a quick look at that, that's something that just kind of makes sense to you. All right. Again, you're not going to have to type in this program that I just showed you. There's no homework from this, so read it. It's important that you understand the concepts because we're going to go over methods and structures and things in the C class next semester. So here's where they create the structure with the name and the phone. And here they create a list of those phone book structures. And here they go in and they read the information from a file. They split it, do some tokenization, and write that information out. All right. Next we talk about enumerations. An enumeration is a user-defined type. So if I created an enumeration like this, this is a new data type that's called day. And it can only hold Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. And actually, the system gives integer values to these, and unless you specify something else, that would be 0, 1, 2, 3, 4, 5, 6. If you wanted Sunday to be 1, you could just say Sunday equal 1, comma Monday, comma Tuesday, etc. Then that would be 1, 2, 3, 4, 5, 6, 7. Those of you who are in the Java class, this is virtually identical to the enumerations that we talked about in Java. So then we can come through here and say this, day workday. Workday equals day dot Wednesday. Remember, the only thing we can put there is day dot Sunday, day dot Monday, day dot Tuesday, day dot Wednesday, day dot Thursday, day dot Friday, or day dot Saturday. Oftentimes you use enumerations for things like are shown right here on page 516. They can make, if you have a very long-winded if or a long-winded switch statement like we have right here, it can make it much more legible to be using enumerated values as opposed to numbers or something like that. They've got a thing here with a color spectrum where they've got different colors in the spectrum, and they write a program for that. I'm not going to run through that. You can get the enumeration's integer value by just running the int on it. See that? Day workday equals day dot Monday. Int value equals int workday. Alright, so if you set it up as Sunday, Monday, and you didn't say it, Sunday would be 0 and Monday would return 1. Again, as I mentioned, you can specify values if you want. If I said freezing equal 32, boiling, and I didn't say equal 212, then freezing would be 32 and boiling would be 33, as an example. You can compare enumerators or enum values, and they show an example here. You can use an enumeration to step through an array. So there's a lot of different things that you can do with this. All right. I believe the last thing that's discussed in here is the image list, starting on page 522. And as mentioned, it allows you to store a collection of images. At runtime, you can retrieve the image from an image list control and display it in a picture box control. So imagine that we had something that was similar to what we looked at before, in that we have something where before we had a list of people's names. And when you clicked on a name, it brought up their phone number. Well, what if instead of that, we had a list of images? And when you clicked on a person's name, it brought up their picture. So there's a few guidelines that you should use when you use an image list control. All the images should be the same size. Otherwise, they would end up looking distorted. They can be no more than 256 by 256 pixels in size. So a lot of times you use thumbnails. And a really nice site, if you've never seen this before, it's one I use quite a bit when I'm doing different things. And that is, again, if you've never looked at this before, it's makeathumbnail.com. Alright, so if I come through there and I browse and I find, I don't even know if I've got anything in here I could use for a picture. Let's do this quickly. I don't want to waste your time, but I just want to show you this quickly. System is acting unbelievably slow. So. And our dog is a Bichon Frise, and she's not puffy like this. She looks more like, kind of like this. So I'm going to save that. Notice it's 640 by 458. So I'm going to save that image, and I'm going to save that as Lacey, who is my dog. It's not her, but it looks similar to her. So I'll save that to the desktop. And you'll notice when I do that, there it is. And if I double click on it, there's the size. Okay? So now if I come back over here to makeathumbnail.com and I browse, and I want the thumbnail size, I'll make it 100 by 100. I'll browse here, and there's Lacey. And I'll tell it to make a thumbnail. It throws it out on the web. I grab that address. There it is. And I'll save that image as, we'll call it Lacey 2. Alright, so there's Lacey. Oh, there's Lacey, sorry. Yeah, there's Lacey 2. So you can see the difference in size between the two. Okay, there's no distortion or anything. So again, make a thumbnail, very nice, free site that I've used quite a bit. All images should be of the same type, so you shouldn't really mix bitmap and JPEGs, etc. It's a control. All right, it appears in the components tray, so in other words, it's kind of an empty control. Different properties that you can work on with it. Okay, I'm not going to run through any of this, but they've got this tutorial in here, the random card application. So the idea is, in this card picture box, you've got one of 52 different values, and you click Get Random Card, and it should give you one of those values. That's it for the chapter. Again, there is nothing assigned. There is no homework assigned. The program, again, that I went over with you, and I did it quickly, but we will spend a class period or part of one going over it. And that is the one right here on the bottom of page 531, sum of numbers in a string. All right. So again, it was kind of quick, but hopefully you got something out of it.